Hello world, welcome to Netmath and Tech Academy. Welcome to the second episode in solving a maze with backtracking. In our previous episode, we did steps 1, 2, and 3. And in this episode, we are going to tackle step number 4, which is to automate the solve. Till now, we have only solved the maze manually. Like we have to enter the direction in which we want to move, and we see that we can solve the maze. If you have not watched episode 1, the link is in the description. Please watch episode 1 before continuing here. So we're going to start by making a copy of episode 1's code. So let's fork our REPL. And now let's try and focus on how to automate this. In our previous episode, we already saw how we wrote a generic method to move in any direction. So we don't need the move down method anymore. And we also don't need this one. We have the generic move direction and check move direction methods. Right now, we are running the whole logic in a while true loop, and we are asking the user to enter the input. But now, rather than that, we are going to automate it. So we are going to introduce a new variable here called move order, the order in which the direction order in which we are going to try and solve this puzzle. For now, let's go with down first, right next, left next, and finally up. It's just an assumption. This variable will come in handy for us when we add intelligence into our solving algorithm. But for now, let's go with this order. So instead of asking the user for which direction, we are going to try and solve the maze by going in all these directions. So let's introduce a loop here for move in move order. So now what's gonna happen is we are going to try all those directions. If one of those moves was successful, we are going to jump to the beginning of the loop. So I'll do a continue. And if, for example, we have tried all 4 directions and we did not find a suitable spot for us to move to, then we need to backtrack. Maybe we took a wrong turn. Let's first see how this one behaves. I'm gonna put a empty input statement here to see how this all behaves. So first let's print the move, and then let's put a empty input statement. Let's see how our code behaves for now. So first thing is we are going to try and move down. Why are we trying to move down? Because we have set the order to down first. So as I hit enter, our player is moving down. And now we are going to try and move right. Okay, so when we did a continue here, we went back to this loop, but what we want to do is go back all the way to the top. So it should not be a continue, it should be a break. So we break out of this loop and go to the outside loop. So let's try that one more time. We try to move down, and now we are again gonna try to move down because our move order starts with down always. So now again we are moving down. Now we are gonna try to move down. We will hit a block. Now let's see what happens. So since we hit a block, we are trying to move right. Now that we actually made a move, we go back and try the same order. Down is not possible, so we go right. Down is not possible, go right. Down is not possible, go right. Now actually down is possible. So we'll continue to go down, right, down, right, down. Now what has happened? We have hit a roadblock. So that means we cannot move any direction now. So now let's see what happens. Down is not possible. We try right, we try left, we try up. We have tried all the possible orders, and now the loop keeps repeating. We should try and avoid it. So what is backtracking? Backtracking is a way for us to retreat to the previous step and try a different direction. So what does that mean? When we hit a roadblock, we need to know which way we came from so we can go back and try a different path. So we need to remember our path. So I'm gonna call this our moves, let's say. So it's an empty list. Every time I make move, after I make a move, I'm gonna put it into my R moves list. So let's see how this works. So now let's run this. So I move down. Okay. Print it here. So right now our moves list is empty. Now I'm moving down, moving down, moving down. The next thing I'm doing is going right. So we are keeping track of the way in which we are going. So right now we have made 3 downwards, 4 rights, 2 downs, and so on. So once we have hit this roadblock, we have to, if we come to this part of the code, if we reach here, we have hit a roadblock. So we need to backtrack. So how do we do that? So that means we have to try and undo our move. So let's see how to do it. So we have the move direction function. Now let's make a copy of it and let's call it undo move direction or backtrack, right? So what is going to happen is if I want to undo the move that I went down, that means I need to go up, right? So my row decreases. Undo my up, I need to go down. Undo my right, I need to go left. Undo my left, I need to go up. So that's it. That's basically our undo move direction. So all we have to do is find our last move and undo it. So let's be our code here. Okay, and now instead of moving, let's undo our move. And the which direction do we want to undo? Whatever what our last move was. So we just pop the last move. But when do we actually want to undo? We want to undo only if we have tried all the directions and we did not find a valid move. So that means we have explored all the moves. Okay, so now let's see how this one works first of all. So now let's go back to our maze. Let's put our target back here and let's add some blocks here. So once I have reached this spot by going down, then I need to backtrack. So let's see if this works well. So now I'm going down, going down. Okay, so let's go back and see what we are missing. So after we make a move, we break from the loop and then we are undoing again. Okay, so that's the problem here. So we need to keep a variable to keep track whether we actually made a move or not. So let's introduce a variable here called move move made. Okay, let's set it to false. Every time I start a loop, move made is false. Only if I actually make a move, I will set this to true. And if I have not made a move, then I need to undo. So if move made is false, only then I need to undo. So now let's see what happens. So I go down, I go down, I go down. Now I need to undo my move after trying all possible directions. So now I'm trying all the directions. I've tried all 4 directions. So now I have undone my move. But I'm not printing the latest maze value. So let's print the latest maze value and let's also reconsider this part. When we actually made a move, what did we do? We changed the current position where the player is in as a path, meaning the path at which we came in, and then we moved the position to the new player. Now we cannot do the same here. Now this is not a path anymore because we are backtracking. That is a path that we explored and it didn't work out. So I'm going to call it a dead end and I'm going to use the value 4 for it. So every time I undo, I will make the current position a dead end so I don't go there again. So now let's see how this works. I go down, go down, go down. Now I try all 4 directions. I am at this position. I cannot go anywhere because I'm surrounded by the path in which I came and all the 2's which are blocks. So that means I need to undo. So I have undone my move and I have put a 4 here because that is a dead end. So I try all positions here. Again, that's none of the moves are possible. So I put a dead end here so I don't go there anymore. And now I try a different path. So now what we have basically done is we have actually solved the maze with a simple backtracking. All we did is we introduced a list to keep track of all the moves that we are doing, and we marked the previous move path as dead end, and we are backtracked and we have solved the maze. So at this point, if I print my variable or moves, that will be the answer to our maze problem. So as I keep hitting enter, I have solved the maze. So the solution is this. I have to go down, right, right, down, right, right, and I would have reached my target. Now let's, instead of hitting enter all the time, let me import this and let me give a little bit of delay so we can see what is happening. And let's run this one more time. So we keep trying all the moves. So our player is moving down, left, up, and right, and is trying to find the possible solution. Now let's go back to our maze design. So we went all the way into here. Now if I block all these path, so then I would try to go all the way and I need to backtrack and come down again. So let's see if that works. So we can see our player 1 moving and he's also marking 4s which are dead ends. So we're gonna go all the way here and we find we can go up. So we are going all the way there and we find we can go up. We are going all the way there. And now we realize we have made a wrong move. So now let's see how we are marking this whole spot as dead end. So we are exploring all the way up. And now we will start backtracking. We are marking all the dead ends. And slowly we are coming back all the way. I should probably increase the speed a little bit. This is taking a little too much time. Okay, let's let this maze run at least once now. So we can see our player moving here, the number 1. Now we are slowly backtracking and we are marking all the wrong turns that we took as dead ends. I think we are pretty close now. Again, the delay here is because I put a wait statement here of 0.4 seconds. Otherwise, this will definitely run much faster. And that's good. We have now solved the problem. So let's now try to run this without the delay. And now it should happen much faster. Yeah. So what was the path we took? We came all the way down here. We went here and we turned here. And this is probably not the most efficient path because we could have gone right and then down here. But if you remember, our move order is always to try down. So that's where in our steps we will in the end add a little bit of intelligence to see where our target is and dynamically change the move order. Anyways, for this episode, this is what I wanted to cover. This was a good use case where we are able to um, check how the backtracking is working. And of course, add the source code in the description. And if you want to clearly understand this, you can increase the time delay or put an input statement in between and then do it step by step and understand it. Wonderful. Friends, that's all for today's episode. In the next episode, we will cover the PyGame UI for this maze, and in the future episode, we'll add the intelligence part. That's all for now. Bye, world. Talk to you in the next episode.